Hi, everyone. Now, when we're determining limits using algebraic properties, now I know that this looks like it's a lot, but it's actually very intuitive. So if we look at this first one, it's saying that the limit as x approaches a of a constant k is equal to k. So if we were to kind of look at an example of this, well, if I said I'm taking the limit as x approaches 2, for instance, of 4, well, the function itself is 4. So the function is always going to be 4. So regardless of whatever number x is approaching, the function itself is always 4. So then I will have a limit of 4. Now, if we look at this next question, it's this next property, it's kind of similar. If I take the limit as x approaches a of a constant multiplied by the function, I could always take the limit of the function and multiply it by the constant. So I could always pull out the constant, and that could be held true. And we can see that when we're doing something like this. So um, if we say, for instance, the limit as x approaches 2 of our function, let's say 3x squared. Now over here, we can see that this is a 3 multiplied by the x squared. And I can, using this property, I can say I'll make that equal to 3. I'll pull out the constant, multiply by the limit of the function, x squared, and we can see this, we can see that this is direct substitution of 2 in this limit. So if I said, for instance, what's the limit as x approaches 2 of 3x squared, we can substitute that 2 in. We can say, well, technically that's going to be the limit, sorry, we can substitute that in. So we're just going to have 3 multiplied by 2 all squared, and that is just 12. And this is using this first technique. Now, if I use this technique over here, using the property where I can pull out the constant, and I know that this one is a simple example, but pulling out the constant could just make things a little bit simpler. So if I did instead, I'm going to take 3 multiplied by the limit as x approaches 2 of x squared, then over here I'll just have 3 multiplied by, again, 2 squared, and that is going to give me 12 as well. Okay, so it doesn't matter whether I have the constant inside the limit or outside the limit, it still means the same thing. Using this property can make things a little bit simpler with a little bit more difficult problems. Now let's have a look at this next one. So the next one says the limit as x approaches a of 2 functions being either added or subtracted. So let's kind of add that piece over here. So the sum or the difference of 2 functions. If I take the limit of the sum or the difference of 2 functions, it's the same thing as taking the sum or the difference of the limits of those functions, right? So over here, I can split them up. I take the limit of each one on its own. So if I had something like this, if I had, let's use blue for the examples. If I had sine x, for instance, plus 3x squared. Now over here, we can see that these are 2 different functions that are being added together, right? We have the sine x, we have the 3x squared, and each individual one we can see could be taken as a limit of its own. So if I said limit as x approaches 2, for instance, of these 2 functions, of this addition over here, well, I could always just separate this and write it as the limit as x approaches 2 of sine x plus the limit as x approaches 2 of 3x squared. And I can do this whether it's addition or subtraction. So if this was subtraction, I would just put a subtraction sign. I would just put subtraction instead of addition. Now, that also applies for the multiplication and division where I can split them up. So you look at the next one and it says the limit as x approaches a of f of x multiplied by g of x. So I'm taking the limit of the multiplication of 2 functions, right? So I can see that over here, this is the limit of a product. What this property tells me is that instead of taking the limit of a product, I can split them up. So if I had, for instance, the limit as x approaches 2 of, let's say, sine x multiplied by 3x squared. Okay. Now, in this case, it says that, listen, you can split this up, and instead of taking the limit of that, because it might not be as obvious, we can actually say that this is the same thing as taking the limit as x approaches 2 of sine x on its own multiplied by the limit as x approaches 2 of 3x squared. So I split them up as well, the same way I did with the addition and subtraction, and division same way. So with the division, if I say I want the limit of a quotient, or the limit of two functions being divided, it's the same thing as taking the quotient of those limits. So over here, you can see that I can split them up as well. And if I use the same example, I would just have the sine x on the top, the limit as x approaches 2 of the sine x on top, and limit as x approaches 2 of 3x squared on the bottom. So those three over here, we can see kind of follow the same idea, where if I have any of the properties, any of the operations, addition, subtraction, multiplication, or division of two functions, I could always split them up using that property. So the limit of the sum of two functions is the sum of their limits. Limit of the product of two functions is the product of those two functions, and the limit of the quotient is just the quotient of those two functions. Okay, now, also don't mind my alarm over there. And then this last one over here says that when I take the limit of a function raised to a power, instead of raising it to a power, because let's say I had something like this, right? Let's say I had limit as x approaches, again, we're going to stick with 2 just because why not? X approaches 2 of a function, let's say 2x cubed minus 3x, I don't know, let's say squared, all to the power of 4. If I had something like this, instead of saying, listen, I'm going to open this bracket 4 times and then take the limit, right? Because I don't want to write this as, I don't want to write it as 2x cubed minus 3x squared multiplied by 2x cubed minus 3x squared. Basically, write the bracket 4 times and then multiply it out. I don't want to do that. It's going to waste so much time, and it's actually going to make things a lot longer and a lot less efficient, right? And we're always trying to find efficient math. So instead, if we can remember this property over here, then we can actually say, listen, I can say that I'll take the limit as x approaches 2 of the inside function, right? Because this is the function that's raised to a power. You see how over here we have a function raised to a power. So we're going to take that inside function. We're going to say, listen, I'm going to do the limit as 2x cubed, as x approaches 2 of 2x cubed minus 3x squared. And I'm going to get that limit, and then I'm going to raise it to the 4. And we can see that this is actually a simple substitution. So if I substitute that in over here, then I have 2 multiplied by 8 minus 3 multiplied by 4. And then I simplify that, and then whatever I get from there, I raise it to the 4, right? So that's all it is. And when, using algebraic properties to find limits simplifies things a lot if we can remember them. And these are, you can see that 3 of them actually follow the same concept. These ones also follow the same idea, right? Where if I have a constant, if I have just the limit of the constant, it's the same thing. If I have the limit of a constant multiplied by a function, I could pull out that constant. And the last one just says, if I have the limit of a function raised to a power, I can just take the limit of the function, then raise all of that to the power. Okay. All right. I hope that helped everyone. And I hope I'll see you in the next video where we're going to do some more questions on this. Bye.